Inferences means determining confidence intervals. So the word inference, determining confidence interval, determining point estimate, running test of hypothesis, everything that we've done in the past, but now for two populations. Okay, so inference, it's inferences on two samples. This is the title of chapter 11, and 11.1, two populations proportions. Inferences on two population proportions. So we are going to look at now the alternative and the whole thing and conditions and everything, but I just want to jump in and just give you the conditions or how the null and hypothesis and alternative hypothesis will look like. So this will be P1 equals P2. And this could be P1 greater than P2. It could be P1 less than P2. And of course, it could be P1 not equal P2. Everything is the same. We are still using Z normal for population proportions. And of course, the conditions must be fulfilled. What conditions? Normality and independence must be fulfilled for each sample. The technology will help us a lot. In addition to that, we are going to have StatCrunch, as I said, and the calculator. We do have formulas. Formulas become a little bit more involved. So we do not need to use them, but we need to know they exist and where to find them. So at least that. Okay. So samples have to be independent for two populations, because if they are dependent, in other words, if we select from one individual for one sample, and if that individual triggers an individual in the second sample, they are dependent. Okay? Or matched pairs. Okay, so here is our first example to decide whether the sampling method is independent or dependent. Then determine whether the response variable is qualitative or quantitative. So let's do that. I hope you see this. It's posted under module for and videos and lecture notes for this class for 2020. Please at least bring it up. You don't have to print it out. Save it if you want. So I think it's Joliet Junior College decided to implement a course redesign of its developmental math program. Students enrolled in either a traditional lecture format course or a lab-based format course, in which lectures and homework were done using video and course management system MyLab Math. They changed the name recently. It's MyLab Math. What you have is MyLab Plus, MyLabs Plus. Okay, there were 1,000 or 1,100 students enrolled in the traditional lecture format, and 500 were enrolled in the lab-based format. Once the course ended, the researcher determined whether the students passed the course. The goal of the study was to determine whether the proportion of students who passed the lab-based format exceeded that of students who passed the lecture format. So students were divided into two groups. One group, traditional, the other group, lab-based. Do you think that this is an independent, in other words, the two samples are independent from two different populations? Or when I select, let's say I select one of you to the traditional, and I select the second individual to the lab, is there a connection between the person I selected for the first sample and the person I selected from the second sample? In other words, once I select for the first sample, does this individual force me to select a particular individual in the second sample, or it doesn't matter, I select anyone I want? Is there any connection between the two?
Yes.
There is no connection, because once I select you and I put you in the traditional format, and I go next to, let's say, medicine. I say, Maddie, you are going to be selected for the lab-based. You didn't force me to select Maddie for the lab course. Maddie did not force me to select you for the traditional course. So you're completely independent.
I see.
No one in this sample forces me to select a particular one in the other. If I select somebody's wife, and there is a connection, and now I have no choice, but I have to select her husband in the other sample, then they're not independent. So the selection that I made here is a certain person, then I have to take his or her spouse in the other one. I'm forced to put the other person, and these samples are no longer independent. But here, nobody forces me. I'll give you a number, and I randomly select who is in this sample and who is in this sample. Nobody forces me to select. If I selected one person here, I'm not forced to select another particular person here. So this is independent. Do women tend to select a spouse who has an IQ higher than their own? To answer that question, researchers randomly selected 20 women and their husbands. Now this is a different story. So if I select a woman here, I have no choice but select her husband in the other sample. So they measured the IQ of each wife, husband, team to determine whether there was a significant difference in IQ. This is definitely dependent. Once I select person A, I have no choice. I am forced to select her or his spouse in the second sample. So this is independent, but this is dependent. Okay. Test of hypothesis regarding two population proportions and why we would do that. What is the issue here? Which is extremely important because it's applied all the time in clinical trials, even now for the vaccine that they are trying to develop for us. They are testing against, so there are two populations, one who gets the vaccine and the other one who we tell them they are taking the vaccine, but they are not. So these two are two different populations. One population that takes the vaccine and the other one that doesn't, so we can compare them. So in order to compare two population proportions from independent samples, we have, again, a system here. So now the sampling distribution of the difference, P1 hat minus P2 hat. So at this point in time, we're going to have X1, N1. We're going to have X2, N2. We're going to have a sample size for the first one and the sample size for the second sample. We're going to have number of successes in the first sample, number of successes in the second sample. And from each one, we will get a P1 hat, which will be correspondingly X1 over N1, and another sample proportion, same thing, but this time with X sub 2 over N sub 2. And the P1 hat minus P2 hat will be normally distributed as we had before, but now it's all about the difference. So this will be P1 minus P2, the population proportion 1 minus population proportion 2. And now the standard deviation or standard error or deviation for the difference of the proportion, sample difference of the population proportions is a combined, as you see, it's a combined square root. So I don't have enough room here, so I'm going to write it here. So it's the square root of P1, 1 minus P1, but over N1, and then P2, 1 minus P2 over N2. This will be done with technology in a minute. Okay. So then the test statistic P1 hat, this is not a test, this one will be the normally distributed distribution, standard normally distributed. Now, the calculator normally calculates what is called a pooled estimate of P, called P hat. So it's combining P1 hat with P2 hat in this way. X1 plus X2 and N1 plus N2 in order to minimize error. So you will see in older calculators, not in this one though. I don't have an older calculator anymore. I used to, but it broke. The screen I couldn't read anything, so I had to get rid of it. But in the past, in the older calculators, when we went to the tests, and this is a test of two proportions Z test. So it's number 6. It would ask us to click on a button, on the key that says, do you want to use the pooled proportion or not? So we had two options. Either we were using the pooled proportion called P hat, which is not the population of the first, is not the proportion of the first sample, is not the proportion of the second sample, is not the population proportion 1, is not the population proportion 2. It's just a calculation called pooled proportion with the given information. But now I have to assume that the calculator is already doing pooled. You don't have the option of selecting yes or no. Okay. So let's take a look at our first example. So in clinical trials of, I believe it's Nasonex, 3,774 adult and adolescent allergy patients were randomly divided into two groups. So obviously this tells me that the sampling method is independent. Sampling is independent. No one from the first sample is connected in any way to anyone in the second sample. So a total of 3,774 total. That's the total number of patients. The patients in group 1, the experimental group, received 200 micrograms of Nasonex, while the patients in group 2, control group, received nothing. Placebo means nothing. We gave them a pill that has water in it, but they don't know. Sometimes the doctors don't know which patient has, which group gets the water and which group that gets the medication. Double-blind study is called. Of 2,103 patients in the experimental group, so group 1 has 2,103 patients. And 547 reported headaches as a side effect. So the result, the success, so to speak, is 547. Immediately I can compute, if I want to, P1 hat coming from the sample as being 547 over 2,103. Okay. Next. Of 1,671 patients in the control group, okay, so N2, 1,671 patients, 300, so this is X sub 2, 368 reported headaches as a side effect. It is known that over 10 million Americans who are 12 years and older are allergy sufferers. Okay, so at this point, I can immediately calculate if I need to, if I want to, the proportion in the second sample. Now, let's read on. Is there significant evidence to conclude that the proportion of Nasonex users who experienced headaches as a side effect is greater then the proportion in the control group at alpha 0.05. Before we test the conditions of independence and